Alright, let's reiterate it once again. The most important distinction between entities and value objects is the difference in the way we identify them. There are three types of equality. Reference equality belongs to both entities and value objects, identifier equality to entities, structural equality to value objects. This means that each entity should have their own identity, which is best expressed using a separate ID property. It also means that we can create a single equality method that would feed every entity. Value objects at the same time don't have an identity, so they cannot have a separate ID field. The structural equality means that we need to implement the comparison logic in each value object class apart, but this task can be alleviated by factoring some common logic out to the base class. .NET has a notion with a similar name, a value type. The value type class is a base class for enums and primitive types like int, byte, and so on. Also, all structs inherit from it. Strictly speaking, there is no relation between DDD value objects and .NET value types, because the former is a design concept and the latter is a technical implementation detail. However, there are some similarities in them. Value types in .NET are easy to make immutable and they implement structural equality instead of reference equality. In theory, you could use .NET value types to represent value objects in your domain model. In practice, however, this is not the best solution. Structs don't support inheritance, and because of that, you will have to implement equality operators in every struct separately, which would lead to code duplication. Also, structs don't interact particularly well with object relational mappers. Therefore, despite the semantics likeliness between these two notions, we are better off using classes to implement value objects in our domain model. In the previous module, we talked about unit testing in the context of DDD. We discussed that we should cover with unit tests only the innermost layer of the Onion architecture: entities, value objects, aggregates, and domain events. Now let's talk about when we should write unit tests. The process of test-driven development proposes that we employ the test-first approach. While it's true that TDD has a lot of benefits, in my opinion, both test-first and code-first approaches are applicable in different circumstances. You can read about it in more detail in my blog post here. In short, there are basically two modes in which we write code. With the first one, we are pretty sure what we want the code to do, so we can create unit tests upfront, before we actually start implementing the required functionality. On the other hand, we might be exploring new areas in our domain model. When experimenting with different ideas in code, we are not exactly sure how the implementation should look like. In this case, we are better off not trying to come up with unit tests upfront and just write the code without them. The reason is that while experimenting, we often rewrite our code and even throw it away completely, and unit tests would only slow us down with that. You saw that we wrote the first draft of our domain model without any tests. We were experimenting with code, and that resulted in a new concept, the money class, emerged. Now, as we are finished with the experiments, we are pretty sure about how the code should look like. It is time now to enter the test-first mode and continue the development adhering to the TDD process. Let's start off by adding a new Visual Studio project for unit tests. Good. I'm gonna use XUnit as the test framework for our application, but other test frameworks would fit as well, of course. Also, we'll be using Fluent Assertions. It's a library that helps write assertions in a more fluent way. That's pretty handy as it increases test code readability. Alright, you can see here our two NuGet packages with their dependencies installed. I also use ncrunch as a test runner. It runs unit tests constantly on the background and gives a nice visual feedback in case something breaks. It's a paid plugin and it's absolutely fine if you don't have it. You can achieve the same result by running your tests manually. You will see how ncrunch works in a minute. We will begin with the money class. Let me rename this class created by Visual Studio to MoneySpecs. Perfect. I'm gonna start by covering with unit tests the existing functionality. So the first test would verify the summing function. Let's call it sum of two monies produces a correct result. Okay, so what we're gonna do here is we are going to create two money instances, sum them up, and verify the resulting money instance contains the correct amount of coins and notes. Here's how we could write an assertion using the standard assert equal syntax, but we'll use Fluent assertions for that. You can see this version of the same assertion mimics the English language in the sense that it reads from left to right just as a regular sentence. That's basically it. This is the only reason why we use this library for our tests. It makes our tests a little bit more readable. Alright, here are the other 5 assertions. As you can see, we are checking that all properties in the money instance were summed up correctly. These green circles here, produced by nCrunch, they represent the test coverage. If we go here and replace one of the parameters with 0, you can see nCrunch tells us the implementation now doesn't comply with the unit test. And here is the exact line that checks that. This plugin is pretty useful as it helps eliminate the manual work required for running unit tests after each change, but again, it's perfectly fine if you just run them manually. Just don't forget to do that often enough so that you get rapid feedback. I'm gonna employ the classic 3A test structure for this course. You can see this section here is the range section. The following two are act and assert. I usually don't write those comments and just separate the sections with a blank line. The other already existing functionality we need to test is the one that regards to equality. It's a good practice to always check that two value object instances with the same data of the same type are considered to be equal, because, as we know, .NET employs the reference equality for all classes by default. Let's make sure the money class has the structural equality. Let's name the test two money instances equal if they contain the same money amount. So basically what we want to do here is we want to create two instances like this and verify the first one is the same as the second one. Again, we use Fluent Assertions library for this, which calls the equals method behind the skin. And we'll also check they have the same hash code too. Good. With another test, we will check that two money instances don't equal if they contain different money amounts. So let's create a dollar first and then 100 cents. The dollar, although it has the same value, shouldn't be equal to 100 cents because in our domain model we do need to distinguish such things. The hash code should differ as well. Alright, now as we are done with the existing functionality, let's think about what other methods we need from the money class. The first thing to ponder should always be the edge cases. What are they in this particular case? For example, can we create a money instance with no value or with -1? The empty money instance does make sense in our domain model. After all, the snack machine we are modeling can have no money inside at some point. On the other hand, a negative value doesn't make sense and should be prohibited. So let's create a test for that. I'll name it cannot create money with negative value. This would be a parameterized test. Basically what we are doing here is we are trying to pass a negative count to each of the parameters the constructor has. Hence we need to exercise all parameters one by one. To verify they all fail, I'm gonna define an action delegate and check it throws an exception. You can see the test fails. That's because right now nothing prevents us from creating illegal money objects. Let's fix that. If 1 cent count is less than 0, then we should throw an invalid exception. And we need to replicate this validation for all parameters. The test is passing now, very good. At this point, it is pretty clear we will need at least 2 more methods from our money class. Obviously, we will need to get the value a money instance represents, so that we are not forced to calculate it manually all the time. Also, it is logical to have a subtraction operation along with the addition one, so we need to implement it as well. I need to make an important warning here. Always follow the Yagni principle and refrain from adding any functionality upfront. Remember, this principle is one of the most important, and you should always adhere to it when developing software projects. It might seem that by adding these two features to the money class, we are violating this principle, because they are not used anywhere in our domain model yet. But I'm taking a shortcut here. I know that we will need them in the near future, because I already went through the development of this application. In a real-world situation, you should always try not to introduce any code until you see that you cannot solve the task you are working on without it. Alright, so let's add another test here. We can name it "Amount is calculated correctly." This also would be a parameterized test, so that we would be able to run it against a set of different use cases. Here they are. You can see that, for example, when we create an empty money instance, we expect its value to be 0. For a single cent it would be 1 cent, and so on. Basically, I'm just throwing a pile of cases I calculated manually, creating an instance, and verifying the amount it represents is equivalent to the expected amount. At this point, we don't have the amount property yet, so let's add it. Following the test-first approach, we need to make sure our test fails before implementing the required functionality, so I'm writing the simplest implementation possible just to make the application compile. The letter M here means the literal value is of the decimal type. The test fails as expected, and Crunch shows that one of the use cases expects the value to be 500 but received 0 instead. The actual implementation is pretty simple. We just need to sum up all the coins and notes the money instance has, taking into account their denomination. And you can see all tests are passing now. It's a good time to make some refactoring for our code at this point. You can see the properties of the money class has public setters, which means that they can be easily changed by the external code. Remember, one of the attributes of value objects is that they should be immutable. To implement immutability, we could just hide the properties from the outside world by making them private, like this. But I'm using C#6 here, so I can use one of the latest features it introduces, read-only properties. To implement a read-only property, I just need to remove the setter, and here we are, our class is now completely immutable. Another feature C#6 adds is expression-bodied members. It's a good idea to use it for the amount property. Perfect. The last method we need to implement is the subtraction operator. Let's add a test. Subtraction of two monies produces a correct result. So basically what we need to do here is we need to take two instances and subtract one from the other. The resulting money instance should have the correct counts for each property. An important edge situation in this case is that we can try to subtract more than we have, so we need to make sure we prohibit such operations as well. I name the test cannot subtract more than exists. Declaring two instances. Note that the first one has only one 10-cent coin, and the second one contains a single cent. We cannot subtract one from the other because there are not enough coins to perform such a subtraction, so we need to make sure such operation throws an exception. Alright, so just as before, we are implementing the test in the simplest and obviously incorrect way, just to make sure the tests fail. And you can see they do fail at this point. This unit test, for example, expects 9, but gets 0 instead. What we need to do here is we need to subtract every single property from each other. This makes the test pass. Perfect.